Hey class, here's a homework question, number 4 on the homework that I know might be a little bit tricky for some people, so I thought I'd go ahead and make a video for it. So what you got is you got a crown made of gold that is being submerged in water. So you're going to basically drop it in water and then see what happens. So the first question is, will the crown sink or float? And I'm going to let you guys go ahead and answer that one. I give you the density of gold and the density of water, so you should be able to answer that. If you're not sure, check out my buoyancy force video that I made, also on my YouTube channel here. But then let's move on to the next one. So in part B it asks, what is the volume of the crown? So we're not told the volume, but we are told the density. And to remind ourselves, density is equal to mass divided by volume. So if we want to know the volume, we can solve it algebraically by multiplying both sides by volume and dividing by the density. And so what we should find is basically the density and volume variables switch places in the equation, and you end up with the volume is equal to the mass divided by the density. So when you plug in your values, your mass is 1.5 kilograms, your density is 19,000 kilograms per meter cubed. What you get, first of all, we see unit-wise, our kilograms are going to cancel, and we're left with 1 divided by meters cubed, so the units come out to be meters cubed, and what I found is that my answer came out to be about 7.9 times 10 to the negative 5th cubic meters. Now that seems tiny, right? I've seen people get that answer and be like, oh boy howdy, that's nothing, right? But it's correct. If you think about, actually it's box worthy, haha. So, but if you think about a cubic meter, right, imagine the meter stick in class and turn it into a cube. So that's the length, the width, and the height, right? That's a very large area. You know, that's going to be larger than the mini fridge in your dorm, you know. And so it's a very, very large area, and so a crown is just going to be a tiny, tiny fraction of that. So anyway, next question, what is the volume displaced by the crown? Well, if the crown's in the water, the amount of water it's pushing out of it the way is just the same as its volume. So it's just going to be the same answer. Boom. That's easy. Okay, so then the next question, we would box our answers, right? There we go. So the next question is, what will the mass of the water displaced by the crown be? What will the mass, okay, what does that even mean? Well, this much water is being displaced, and so we want to know what is the mass of that much water. Well, again, we can go back to density. Density equals mass over volume. Since we're dealing with water, I'll use the blue color, apparently. So if we want mass, multiply both sides by volume, mass is equal to density multiplied by volume. So we're given the density of 1,000 kilograms per cubic meter, and our volume is the number that we're given here. I'm not going to write it down for the sake of time, but I trust you guys can write it. And then you do the math, and you should come up with your total mass to be 0.079 kilograms. So I'm going to two significant figures here since that's how many are given in the problem statement right here. But if you do a third one, that's okay too. Just don't write out 18 significant figures. Alright, so we got the mass now. Next question is, what is the buoyancy force? What is the buoyancy force? Oh, what is it going on here? Well, let's remind ourselves, what is the definition of buoyancy force? Buoyancy force is equal to the weight of water displaced, right? Or fluid displaced, right? Weight of water, it says water. The weight of the water displaced. So, in this case, what that means is the weight of the water, just like we saw in lab, that's just going to be equal to the mass of the water times gravity. What's the mass of our water? Well, that's what we just found right here. So we just take our mass of our water, 0.0, those are zeros again, not sixes. Let's just rewrite this. So we'll take the mass of our water, 0.079 kilograms, and multiply it by gravity, 9.8 meters per second squared, and you guys can calculate that one. And then moving on to the very last question, what is the net force? Oh boy, what is the net force acting on our crown? Well, if we do a free body diagram, our crown has its weight going down, the force of gravity, and it has the buoyancy force going up. So the net force is just going to be the sum of those, right? So buoyancy force is positive, weight force is negative. So this is similar to what we saw in lab, right? So what you're going to do then is just find the sum of those. You have the buoyancy force that you found in part A, or part E, and you have the weight force that is just the weight of the crown, which should be its mass, 1.5 kilograms times gravity, and you should be able to figure out the net force. So I'm going to leave E and F for you to quantify yourself, but this should get you rocking and rolling. If you have any questions, as always, let me know. Otherwise, have yourselves a box-worthy weekend. All right. God bless, and yeah, have a good weekend.